When we evaluate functions, we need to be able to identify the possible values for x that are consistent in a function. Let's take a look at domain. Domain are your x values that will create a consistent function. If you don't have the right x values, you can cause problems in certain functions. Those are the things we're going to talk about today. Domain is the possible values for x that are consistent in the function. These are our inputs. So there are a few times when you can cause problems with different values for x, and we're going to talk about what those different situations would be. If you have a fraction or a rational function, you could end up with a 0 in the denominator, and that will be undefined. A problem would be if there's a 0 value in the denominator, and that makes a function undefined. The other thing that can cause problems is even radicals. Even radicals cannot have negative values inside of them. So depending on what values you put into the radical for x, you could end up with a negative value inside. It's kind of hard to visualize something like this, but basically you would get something called an imaginary number. We call it I, and you'll learn more about I in future lectures. But imaginary number i's are not good when we're talking about a domain of a function with a radical in it for the purpose of this lecture. Whenever you divide an inequality, because we will be dealing with inequalities, things where you say greater than or less than, greater than or equal to, less than or equal to, these type of symbols. That would be a less than or equal to, this would be a greater than or equal to, and then strictly less than, strictly greater than. If you have a negative and you have to divide or multiply an inequality by a negative, you must flip or reverse the order of the inequality sign. So let's take a look at example 1. In example 1, we have an issue with a radical. Remember, a radical cannot have negative values inside. And so because we're capable of doing so, we can say, all right, the inside of the radical has to be greater than or equal to 0. We can look at this inequality, and we can ask ourselves what values of x would cause the whole thing to be negative. So let's simplify or solve this inequality. Let's add 9 to both sides. And now we have negative 3x is greater than or equal to 9. And now we're going to have to divide by -3. And remember, if we divide or multiply by a negative, we have to flip that inequality over. Now we're looking at x is less than or equal to -3. Any values that are greater than -3 will cause the radical to have imaginary values. If we thought about this on a number line, if here's 0, here's -3, any values that are less than -3 on the number line would be okay for this function. Looking at example 2, an absolute value does not cause any problems. There are no radicals, there are no fractions. And so we don't have to worry about this one at all. X is all real numbers. Finally, let's look at example 3. This one is a fraction. And it's not entirely obvious when you first look at it, but you do need to factor that denominator to see what's going on. If you have x minus 2, x plus 1, you will get a middle term that's -x, and you can check that on your own. What we know is that neither of these can be equal to 0. That's what we don't want. We don't want the denominator to be 0 because it will be undefined. So x minus 2 cannot equal 0, and the other one would be x plus 1 cannot equal 0. Therefore, if we solve for x, x cannot equal 2, and x cannot equal 1. Those two values would make it undefined.